It is fun. It's one of the greatest of them. All right. So we're talking about trigonometry. All right. Well, what does the word trigonometry really mean? It's Latin. Some prefix, suffix. Yes. Three. Triangle. Yeah. We're talking triangles. Triangle what? What does metry mean? We talked about this earlier here. What do you say? Measure. So we're talking about triangle measure. That's all we're talking about. Now, more importantly, it's a special type that we're going to be focusing on. And this deals with the trigonomic ratio. It's a ratio of lengths of sides of a right triangle. We're going to be doing this with right triangles here. So much of our time we're working with, we'll be dealing with those right triangles. All right. Now, looking at this, these are the things we're dealing with. Again, some of this might be a foreign language to you. For those of you who have the calculators, you're looking at your calculator saying, man, I've always wondered what these three buttons meant on my calculator. You know? A lot of you guys are probably saying, what do those buttons mean? The SIN, the COS, and the TOA. Wait, how do they put it? TAN. They put TAN on the calculator. Well, that stands for sine, cosine, and tangent. All right, these are talking about various ratios we're going to be doing. Again, you're going to get to know these guys pretty well, and we're going to go in more and more depth with these. So, all they really are is just like it says, we're making ratios. We're taking sides and we're making them into fractions. That's all we're doing. And we're using those fractions to solve for unknown values. So the first one, sine. Yeah, this is going to sound like a foreign language at first, but it's all going to start making sense the more and more we do this. The trigonomic ratio of a sine is always going to be the opposite over the hypotenuse. Hypotenuse. Good, good, good. Hypotenuse. Hypotenuse. All right. So, what does that mean here? Well, we're talking about sides. Usually we're doing this, we're always coming from an angle. Notice in triangle, there are three angles. We are not going to be working with the right one, though. We never work with what, in this case, it's C. We're either going to be working with A or B. And we're going to be asked to find various ratios of it. So, let's talk about what that means here. Opposite and hypotenuse. We've already discovered where the hypotenuse is. And it's never going to change. That's the one thing that's always constant, no matter how we do these and set them up. Remember, the hypotenuse is always, always, always across the right angle. If you draw a little arrow, it extends there. I like to label it. We'll do more and more labeling down the road. But that is my hypotenuse side. Now, the opposite is going to change based on what angle we are coming from. So in this example, we're talking about sine of A. And again, I realize this. I don't know why. A lot of things don't bother me, but this does for some weird reason. On your calculator, it does say SIN. But that does not stand for sin. You do not sin in geometry here. It is sine. So when we see that, it's called sine, please. It's sine of A. So sine of A, what does that mean? Well, if I'm starting at angle A right here, what side would be opposite A? You just give me the lowercase letter to represent that. So if I draw a line opposite, what letter would I hit? The lowercase a, right? So that my opposite over here is going to be lowercase a. What letter represents my hypotenuse? It's going to be a lowercase letter. What lowercase letter represents my hypotenuse? C, lowercase c. So that's my ratio. It would be A over C. And again, we'll start having numbers on this down the road, but right now you're just going to see where these things are coming from. Now, we're talking B. Well, that means I'm going to be coming from a different angle. So that's my angle I'm looking at now, angle B. I still want to do the same ratio, but now what side, lowercase letter, would be opposite B? What do you say? Lowercase b. So now this is my opposite, but my hypotenuse remains unchanged. So it's still going to be that. So it just matters what angle you're coming from. It changes your ratios. All right, let's look at cosine. Next one, cosine. What's cosine going to be? This is going to be the adjacent. Again, we've used this word before with angles. Adjacent. Spell might help me out too. A-D-J. Adjacent. Over, again, the same thing, hypotenuse. Adjacent over hypotenuse. Well, the nice thing is hypotenuse never changes. It's always going to be across the right angle, so it's always there. Now, adjacent's a little weird. This is actually the hardest to identify of these pieces. But again, it's telling me what angle I'm coming from. So over here, I'm talking about angle A. So it says cosine of A. Adjacent means next to. That's why I say sometimes it's hard to see. What side is next to A? We already said it was opposite. We already said it was over there. So what side would be next to, adjacent? Have it? B, lowercase b. So my B would be right there. Again, hypotenuse doesn't change. My hypotenuse will still be C. Now, we're talking about coming from cosine of angle B. Well, that's a different angle, so we're going to have to readjust it, see where we're coming from. And then if we do this later, we're going to have to relabel it. And you'll see how we do that later on. All right, now, if I'm coming from angle B, what side is adjacent to angle B? Which one's right next to it? Cat? Lowercase a. Lowercase a. And then over hypotenuse, my hypotenuse is the same. And again, I know this is very confusing right now. A lot of letters, a lot of fractions, a lot of flipping. It's going to make sense. The more you do this, by the end of this, you guys are going to be pros. You're going to start chanting mantras that we have going with this. You'll know the saying by heart. Just like when you say, when in doubt, proportion out. And there's a lot more fun sayings with this one, don't worry. All right, and the last one we're talking about is tangent. T-A-N on your calculators looking there. The tangent is kind of the blend of the two. This is going to be the adjacent over the opposite. Adjacent over the opposite. Now, still coming. Oh my goodness, what am I doing? So, my goodness. Opposite over adjacent. I would have figured out my mistake real early. Opposite over adjacent. Just color coordinating things. T-O-A. You'll see why in a second. Now, when we do this, the opposite, again, we're coming from that various angle. We're saying angle A. We already said, what angle is opposite A? Lowercase a. Now, we don't have the hypotenuse like we've had in the other two. But now we can talk about the adjacent. Relative to angle A, what side is adjacent to it? What's next to? Lowercase b. So this is lowercase b. Watch what happens. This one has a special case. Now we're going from a different angle. We're going from angle B. Still want to have that same exact ratio. What is now the opposite side in a B? What side is opposite? Lowercase b, B. Now what side is adjacent to it? A, side A. What do you notice about those two ratios? They're just flipped. That's all it is. With tangent, they're going to be flipped. So if I go from one angle, I can save myself some time. I'm just going to go over and be flip-flopped to the other side. Now, again, is anyone completely lost? Looking at this, is anyone like lost or anything? Saying, what is going on here? Yeah, so again, what's going on? I don't know. Well, I'll tell you what's going on. Well, there's a way to organize it. This is going to help us solve for missing angles and missing sides in various right triangles. But there's a way to memorize this to help us out. Does anyone know of Pocahontas? Has anyone seen the show Pocahontas? We'll learn the history books about Pocahontas, right? Well, what you didn't know, and your history teacher probably didn't tell you about, is her sister. She had a mathematical sister who was very good and did a lot of things with geometry and math in general. Her name is Sokotoa. Sokotoa. That's her name, Pocahontas Sokotoa. All right? You guys, your teachers haven't told you about Sokotoa. Really? Your history teachers haven't told you about this. Okay, I guess I'll have to educate you guys on this. Well, Sokotoa, she's a great one. She helped us identify a lot of things. Not only that, she lended her name to how we could set up these ratios and understand how they work. Now, look how it's written out. Sokotoa. This is representing of her name. This is going to be the sine, the ratio. The sine ratio is always going to be opposite, OPP, over the hypotenuse. So the Sokotoa. Side equals opposite of hypotenuse. The middle part of her name is Ka. which represents cosine, cosine, and that represents adjacent, ADJ, over HYP. And the last part of her name, so you guys can piece it together, is going to be the tangent, which is going to be opposite over adjacent, the ADJ. Now, that's one way. When I was back in the day and learned her name, that's how I learned it. I don't know, Baker, if you learned it, is that how you learned it back in the day?
That's how I learned it back in the day.
I mean, that's how it was written out. Now, I did some deeper, when I started reading the history books, it's actually written a different way. And I like this way a lot better, too. That when I have this is sometimes you get mixed up. Which one goes first? So here's another way of writing it, and I just like it a little bit neater. I'm going to go in the color coordinated. Is I'm going to have the big letter, I'm going to do O over H. So, S-O-H. The other one is cosine. So C-A over H. And the last one is TOA, capital T-O over A. That way you always get your ratios correct. Again, I don't care if you ever SOHCAHTOA or traditional history book way, SOHCAHTOA like that. But you need to write this. Every time you have a test or quiz in this unit, this should be the first thing you put at the top of your paper. This is it. Just like when we had the perfect squares, all those other things, this goes to the top. Do it.
The ratios are also given, kind of how we did like little a over little b. Those are given on your reference sheet as well. It's just the reference sheet is not as nice, and they don't have the little a, little b, little c labeled for you. But they have the setup. So you just know across from the a is a little a, across from the c is a little c, and across from the b is a little b. Write that on your reference sheet. It's not the orange ones. And have it.
Yeah.
They're there too. The SOHCAHTOA is a little easier to remember.
It's on there for you, but if you remember the SOHCAHTOA, because it's written right there. There's SOHCAHTOA, but it's not written nice and neat, so it's not easy to memorize. So having this acronym helps you guys solve a little bit. So let's try these out. Let's have some ratios.
Okay, so in this example, we're going to follow these steps to set up our first trig ratio.
They're always the same steps.
Here, it said R was 16, so go to your diagram, mark that as 16. It said S was 30, go to your diagram, label it as 30. And it said T is 34, so label that as 34. We're going to follow these steps to set up our first trig ratio. Well, we're going to find the sign first. We abbreviate sign as S-I-N. It's not sin. Can't sin in that. Okay? That is pronounced sign. We just abbreviate it S-I-N. Of our angle R. And we're trying to find that ratio. Your first step is you go to the angle we're dealing with. We're dealing with R, so you're going to put your pencil right on R. You're going to label your side, your opposite, your adjacent, your hypotenuse. Step 1, put your pencil on your angle, and then label your side. Well, go directly across. That's your opposite. So start at your angle, drag your pencil to the side across from it, that's your opposite. Then what you're going to do, you're going to go to your 90-degree angle, put your pencil on it, drag your pencil across, that side's your hypotenuse. And then the one we haven't labeled yet, your adjacent, I think that's the hardest one to label. That's why I save it for the last, because it's the last thing. After that, you're going to set up that ratio. So we say sine of R equals that fraction. Okay. Well, another thing you need to do, write SOHCAHTOA on the top of your paper. So, write that on the top of your paper. Every time. If it's not already there. Okay? So if we're dealing with sine, what do we need? What's our ratio going to be? What over what? Emmett? Yeah, opposite over hypotenuse. So you go to your diagram. Which side? What measurements are opposite? 16. That's going to go on the top. measurement is our hypotenuse, 34. That's going to go in the bottom. Your opposite side, 16, over your hypotenuse, 34. What must we always do with our fractions? Do not pack up. You're going to get this wrong. Simplify. What is 16 over 34 simplify down to? What is it? Close, it is 8 over 17.
Hey, we've already